In this module, we shall look at the relationship between the application layer performance and the throughput which is available to it at the physical layer. Specifically, we shall look at what is the formal definition of application layer throughput, what are the factors which affect the performance at the application layer, and finally, we look at a simple way to mathematically formulate an expression for application layer throughput. It is interesting to observe that application layer looks at the lower layers in an unfair way. What I mean to say is that the application layer invokes the lower layer functionalities according to its requirements, and therefore there is a kind of conflict between different applications in competing over the resources of the lower layers. Formally speaking, application layer throughput comprises two parts, the good put and the bad put. What is good put and what is bad put? Good put is actually the useful data of the total transmissions that is received successfully at the receiver end. The bad put contributes the overall packets and the retransmissions and the redundancy which is part of the overall transmission. Mathematically speaking, if the total number of packets are n, the overall fraction of packets which collided are given by as an expression c divided by n, and the total number of packets which are lost are given by the fraction L divided by n, where L and c refer to the number of packets lost and collided respectively. Let's look at the factors which affect the application layer throughput. In a network which is multi-hop, there would be end-to-end error rates. The error rate of every communication link is cumulatively going to contribute to the overall end-to-end application layer throughput. The protocols which are being used, for example, we know that TCP and UDP behave differently because TCP uses handshaking, windowing, acknowledgements, and all that stuff, whereas UDP does not. The protocol parameters, for example, what is the default frame size, what are the values of the retransmission timers, these are going to determine the overall load in terms of good put and bad put. The packets per second of the networking devices, because the intermediate devices, be it switches or routers, overall have a very significant role to play. The number of packets which might get lost at intermediate devices, it depends on the failure probability and the occurrence likelihood at intermediate devices. Similarly, the end devices such as workstations and servers, their disk access speeds, the caching sizes, and the performance of their device drivers have significant role to play. The computer bus architecture which is being used also has a significant role because at the end it is the bus architecture that works within a device, and on the outside, of course, it's serial communication. The processor which is being used in the end devices as well as the intermediate devices, the effect of memory, some inconsistencies in the operating system implementation, and the overall lacunas and weaknesses in the applications, such as the inefficiencies there, maybe their retransmission timers are not properly timed. Let's look at an expression that was simply devised in this paper titled Error Resilient Video Coding Using Cross-Layer Optimization Approach. In this paper, the author actually talks about the application good put, which is just a fraction of the overall transmissions. As you can see here, we have a data frame with short interframe spacing on both the sides, followed by an acknowledgement packet. If the total time that it takes to transmit this data frame in duration tau, which is given by the preamble time, the signal time, the service descriptor, and the message overhead all included, and the interframe spacing and the acknowledgement time. If tau is given by that, we can see here that the good put is actually nothing but the overall length of the transmission minus the header overhead divided by the average time, tau average. Now this tau is actually, in true representation, the fraction of the probability that the frame is retransmitted. So this tau is going to be equal to T average if the probability of frame loss is 0. Otherwise, it is going to have an adverse effect on the good put. In the light of discussion that we just had, there are certain connotations that we draw. That is, the application layer throughput gives us an insight into the actual useful transmission, which is again a fraction of the physical layer throughput. It is a very interesting way that establishes a relationship between resource allocation to physical layer throughput.